everyone, my name is Julian Meir, CEO from Automated Marking, and today I want to share 3 simple key steps for the best possible results when using our cartridge-based inkjet systems. The 3 things we're going to discuss today are height, angle, and print delay. So the first parameter that we're going to discuss is print height, so meaning the cartridge nozzle plate to whatever substrate we're printing on. Today here I have our X1 jet system, which is one of our basic Hewlett-Packard cartridge-based systems that utilizes our cartridges here that have a 1/2 inch print height. For our cartridge-based systems, you want to be between about 2 to 5 millimeters from the print surface. So today we're just going to be using some clay-coated boxes to the print nozzle. So here you can see that we have the print head set up, and this is a display stand that has a lot of adjustability, but we have many mounting options that can get various heights and angles. So you can see we have this set up to have about 2 millimeter gap to the surface. So let's show you what that looks like when it's actually running. We're gonna run a couple boxes just so you can see what good print looks like. And then we're gonna raise the height up a little higher and get outside of that sweet spot of 2 to 5 millimeters to the product height. And then you'll see we're gonna start to get some fuzzy print and not as good quality there. So let's run a couple samples here. So here we're running about 2 to 3 millimeters off the surface. I'm gonna stop the conveyor here. So as you can see here, we have a nice clean print. That is due to the fact that we have the delay, see you can set is centered, and then the print height was about 2 to 3 millimeters off. So now let's go and show what would happen if we raise up the print head and we're a little too far off the substrate. You're gonna see the ink start to disperse and you're gonna get fuzzy print. So let's run a couple like that. So I'm just gonna adjust this head up a little bit off the surface here. And then we're gonna go back and run a couple, just so you can see. This is what would happen if we ran the heads too high off of the surface here. So you can see now what's happened is because we have very small ink droplets coming out of the nozzles, which is what enables you to print a nice crisp 2D data matrix barcode or a QR code in this example like this. When we're too high off of the surface, you're going to start to see a lot of fuzz and a lot of spreading of that print, so poor quality print. The opposite is true if we go too close to the surface. What you're going to start to have happen is the nozzles are just going to scrape the substrate that you're printing on, whether it's a box like this, or a bottle, or a bag, or film, and you're going to start to see smudging and streaking. So that's the first key parameter, and again, we want to be between 3 and 5 millimeters from the nozzle plate to the surface that we're printing on. So the next key parameter for high quality print here that I would like to discuss is print delay. Print delay, simply put, is when the product sensor here sees the edge of the product here and how long it waits before it actually triggers that print. So here you can see we have a rather centered print, and that's because we set the proper print delay in the software. So we're gonna go through the next steps and show you how to actually set that print delay in the software and show you what happens when we increase and decrease that delay and the effects that that has on the print. Okay, so once you've downloaded iDesign or Integra Command, which is a software that pilots all of our systems, what we're gonna do is show you how to get to print delay. So you're gonna click on your printer. Here you can see I have it connected via Ethernet because you can see the little Ethernet icon in my printer here on the screen. We're gonna click the little printer icon in the top left corner, and we're gonna navigate to settings. It's gonna automatically populate you on head 1 and print parameters. The first one here is what we're talking about today. That is print delay in millimeters. So the prints that I ran earlier in the video were set to a print delay of 67 millimeters, which roughly gave us the center of the box from where the photo eye was picking up the package to where the printer was triggered to print. So basically all you have to do is click in here and you can adjust that. So what I'm gonna do now is I'm gonna increase the delay by about double, and we're gonna run a print so you can see exactly the effect it has, and then we're gonna come back to the software, we're gonna decrease the delay, go down to about, let's say 20 millimeters print delay, and show you the effect that that has, just so you can kind of see how these different parameters affect where you're printing onto the package. So let's go ahead and increase the delay to about 150 millimeters. And we're just gonna hit enter. That's all you have to do since we're speaking to the printer via Ethernet. And then we're gonna just move the laptop. We're gonna run a couple samples here, and then you're gonna see exactly what that did and the effect that it had. What we did is we showed you how to increase the print delay in the software, and we're gonna show you the effect that that had. So the first prints we made were centered. We had about a 67 millimeter delay. We've gone ahead and increased that. And so that's gonna shift the print back. So when this eye sees it, it's gonna wait longer until when it prints. So let's run a sample and see exactly the effects that we've had. So I'm just gonna flip this on. Okay, so now what you can see here is that before, when the print was centered, now the print is half cut off because it's waiting too long to signal that print. So now what we're gonna do is we're gonna go ahead and we're gonna decrease that print delay and show you the effect that that has. With iDesign or Integra Command open, we're gonna click on our printer, and again, click on the print icon, go to Settings, open the Settings tab. We're gonna go to Head 1, Print Parameters, that's gonna be automatically adjusted. So now we're gonna reduce the print delay, meaning the printer is gonna print faster because it has less delay, so it's gonna reduce the amount of time between the product sensor seeing your product and it printing. So let's reduce this down to about 30 millimeters. And we're gonna see the effect now that that has. 67 millimeters was roughly the center of the box. So let's go back to the conveyor and run a sample and show the effect that this has. Okay, so now you can see what's happened is that the print has moved to the front edge of the box because we decreased that delay. And you can see it cut the whole QR code off, and now you're just left with the text. So decreasing the delay is gonna bring you closer to the front edge, and increasing the delay is gonna bring you closer or off the back edge. So the sweet spot you're gonna wanna find is right in the middle of the package. When you go in the beginning, you're gonna wanna measure from the photo eye here to the print head, and that's gonna give you roughly the idea of when that photo eye is going to trigger versus when the printer starts printing, and then you can fine tune from there. So we're going to talk about one final parameter here, and that's print head angle. Due to the fact that we want to be about 2 or 3 to 5 millimeters away from the print substrate, preferably right in that middle sweet spot, when we're printing on an angled surface, we need to create some angle on the print head itself so that we can maintain the print head nozzles to the substrate having that parallel and proper gap. So what we've done is we've angled the head, and we have a clear Boston round glass bottle here that we're going to print on just to show you proper angling. Now this is true for a Boston round glass bottle or something like a meat tray that's overfilled and has stretch film where it's creating that angle coming down off the side of the package. Really any type of packaging that's not square like a box, or if I was printing top down on the cap of the bottle or directly lower on the cylinder of the bottle, where the head can be perfectly in line and not at that pitched angle like you see here. So let's run a sample just so you can see what this looks like. As we can see here, we have a nice centered, clean print. Now, if we were tipped to being square as opposed to having the head angle tipped in, what's gonna happen is that the head is gonna be too far from the surface and you're gonna get fuzzy print. So that's the importance of matching the print head nozzle's angle to the surface so you can maintain that gap between the print head nozzle and your print substrate.